So we are going to be doing the proofs. And so in this section, proofs are not like the geometry proofs, so don't get all crazy on it. Geometry proofs are a little bit more difficult than this. But what you need to do for these proofs is know a couple of things. You definitely need to know your algebra skills, and you definitely need to know, right now we're going to start with the Pythagorean identities. So we did these, but let's go over them really quickly. These three are the Pythagorean identities. So the main thing that you need to know is the first one. So if you remember the first one, you're on the right track. So the first one here, if you look at it, it's the Pythagorean identity. So therefore, it's the Pythagorean theorem. Where am I using the Pythagorean theorem? Well, the Pythagorean theorem, let's say that I have a triangle that looks like this. Well, anytime that I have that, it's going to be adjacent over hypotenuse. So I know the adjacent side is always going to be the cosine side. And then this side here from this angle here, this is the opposite side over the hypotenuse. So the opposite side is always going to be the sine, and this is always going to be 1 because it's the unit circle. The ray is going to be 1 that's moving around. So I know that this here is a right triangle, and so therefore we get cosine squared plus sine squared, leg squared plus leg squared equals hypotenuse squared, which is what we get right there. Now, once you understand that, then you could actually figure out these identities, because what you do here is, if I wanted to use and get any one of these identities, is that I could actually divide this by sine of theta squared, and divide this by sine squared, and then divide this by sine squared, and that gives me 1, that gives me cotangent, that gives me cosecant, and then I could do it all over again and divide them all by cosine squared, and that gives you your third Pythagorean identity, where you get tangent 1 and then secant squared. So these are the three identities you're going to need, and you're going to need to know those. So keep those in the back of your head, because sometimes you're going to have to use those in some of the identities that we're proving. So these are the identities that we're talking about and that we're going to prove. So I have an equation here of one identity equal to another identity. And so we think that they're identities and that they're equivalent. We will not give you anything that's not going to work out, so don't worry about that. They are going to be equivalent, so they're going to have to work out. So how are you going to do it to prove it? The way you're going to do it to prove it is by making one side look exactly like the other side. So that means that you're going to either choose the left side or the right side. It doesn't really matter. And then you're going to have to use the algebra and the identities that we go over, and you're going to use them in order to make one side, let's say the left-hand side, look like the right-hand side. Or you could work on the right-hand side and make it look like the left-hand side. You cannot go over the equal sign. When you're proving an identity, you cannot go over the equal sign. Now, just keep that in mind. But when you're working with the identities, and we'll talk about this later, these you could move over the equal sign, but not when you're actually proving an identity. If you're using something, an identity, to prove an identity, then you'll be good. And we'll explain it as we go along. Okay, so let's say, for instance, this. How do I choose which side to work on? Well, I would choose the side that it's easier for you. It doesn't really matter which side you work on. It's which side can you figure something out? What can you manipulate and try to figure out to make it look like the other side? So I'm going to start working on the left-hand side in this one here, because it has a lot more to work on. So I have to remember my algebra skills. And so what this is actually, if I look at that, it's going to be 1 squared and then minus sine squared of theta. That is the difference of squares. So that means that I could break them up and factor it, and it's going to be 1 minus sine squared of theta times 1 plus sine squared of theta. That's why we've been working on factoring so long. And so I just factored that. That's a difference of squares. Now, I didn't do anything to the denominator, and I'm going to write down an equal sign. Notice how I didn't move anything to the right side, and I'm leaving the right side by itself. I'm not changing it because I chose to work on the left-hand side, so that means I cannot touch the right-hand side at all. Okay, so now here I have one quantity times another quantity, and I have this at the bottom. Now, because there's no plus or minus in between here, right here, there's no plus or minus, but the times, that means that I have 1 plus sign in the denominator, 1 plus sign in the numerator, numerator, those could cancel out because that's this whole quantity. Those two quantities can actually cancel out. And I am left with 1 minus sine of theta. And lo and behold, it actually looks like the right-hand side. So now I know that I've proved it. Notice how I only worked on the left-hand side. I did not touch the right-hand side, and I made the left-hand side look exactly like the right-hand side. So now I know that I have proven it, and I use some legal algebra skills and rules. Okay, so let's look at this one. It looks a little bit more complicated. So right now what you need to know is try to make everything move down to cosine and sine, and then that'll help you work through it. So what I would suggest you do is that on this one here, I'm going to write down, and it doesn't really matter which side you work on, left or right on there. I'm just going to start working on this side. And notice how this is sine squared minus cosine squared. So this cannot change to 1. Sometimes you could actually look at this, but this one here is sine squared plus cosine squared is equal 1 because it's the Pythagorean theorem. Like squared plus like squared equals 2 hypotenuse squared. So it's not minus. So if it were a plus, then we could very easily make that a 1 and then try to manipulate it, but that wouldn't help because it wouldn't make the left side look exactly like the right side. But just notice that that's a minus, not a plus, so we can't change it to 1. So I'm going to work on the left-hand side, and I'm going to write down that it's going to be sine squared there. And I'm going to do 1 minus, and cotangent, I know is going to be the cosine squared of theta over the sine squared of theta. And I'm going to leave that. I can't move this over or anything like that. And so now I am going to distribute this over. And I know when I distribute that this is going to be over 1. And so this is 1 over 1 there. And so when I distribute that, I am going to get the sine squared of x, which is this one here. I'm distributing to that part. And then I'm going to distribute it over here. And so I'm going to get minus sine squared of x times cosine squared of, I don't know why I wrote down theta there. It shouldn't be theta. So my bad. Let me get rid of that and that. It should actually be x, and then this here is going to be squared of x, and that is x. I changed it to theta on accident. Maybe it's because the other side had theta. And then it's going to be all over the sine squared of x. So now notice how this sine and this sine, they could actually cancel out. And so I am left with the sine squared of x minus the cosine squared of x. And if you notice, that is equivalent to the right side. And so I know that I am done there. Okay, let's do this one here. So this is cotangent and cosecant. And notice how, we could actually look at these and notice how this one here, I have a positive cotangent, I have a negative cosecant, and I have a positive 1. I could move this one over and then move this one over and have that as an identity. So I could actually I could use this identity and replace that in here. So how about if we do that? What if I'm going to work on this left-hand rule, and I am going to, on the left-hand side, I could work on the right-hand side. On there with the negative 1, I could move this one over. Let's work up, since we haven't worked on the right-hand side, let's work on the right-hand side. So I'm going to have 1, and then this one's going to be, remember, I could move the identities around. I just cannot move what I'm proving around. And so I'm going to move this over, and I'm going to have the cosecant squared of theta minus cotangent squared of theta. So I'm going to take that, and I'm going to replace this. So it's going to be equal. So I'm working on the right-hand side. So I'm going to replace 1 equals this. So I'm going to take the 1 out and replace it with what it equals. And it equals cosecant squared of theta minus cotangent squared of theta. And so there we go. And so I distribute the negative there. And so it's going to be negative cosecant squared of theta plus cotangent squared of theta. And then that is equal to the cotangent squared of theta minus the cosecant squared of theta, which is what this side is like. And so then I prove it. Left side is equal to right side. I used the Pythagorean identities on there. So I kept those on there. Did I have to do it this way? No. Sometimes you could do it with just bringing it down to sine and cosine. Now, let's say I'm going to do it in a different way. I'm going to do it with the right side, and I'm not going to use the identities. Now, sometimes you are going to have to use the identities, and you're not going to be able to do anything else on there. And it's not going to be as easy as that. I mean, this one was kind of easy, but I could also take this and do the cosine squared of theta over the sine squared of theta, which is this part right there, minus, and then this one here is going to be 1 over sine squared of theta. And then, of course, it's equal to -1 on the other side. So I'm doing the left-hand side this time. And so when I do this, I am going to get the cosine squared of theta minus 1 over the sine squared of theta. Now here, you might say, well, I'm stuck. I can't make it equal to 1. But if you notice, I have cosine squared and I have 1 squared and then negative. This is the identity up here. So that means that, and I'm going to get rid of this here, that I could manipulate the identity to try to match it and look like the cosine squared minus 1. So that means in order for me to do it, I am going to use the green here. That means that I'm moving this over to this side, and I'm going to move the cosine over here. So I'm going to have cosine squared of theta. I'm moving the 1 over here, and I'm moving the sine to this side, so it's going to be negative sine squared of theta. So now this here is cosine squared of theta minus 1, which is what this is right there. So I'm going to replace it with what that equals, and so that's going to be sine squared of theta negative, because that's what it is, negative sine squared of theta, over sine squared of theta, and then that cancels, and I am left with -1 equals -1. And so those two different ways that you could look at it. So yours could be different from somebody else's. It depends on how you think about it and what comes to your head first, and that's how you prove the identities. Let me do just a couple of more on here. And these get a little bit, they look more crazy because they have the tangent and the cotangent. Let me just walk you through it a little bit, and I'll let you work on those on there. And as I'm doing these problems, it would be a good idea for you to stop it, try it on your own, and then see how far you could get. So here, I'm just going to attempt this here. Notice how it's squared and this quantity is squared. So it's going to be a little bit long, but it's this means that you're just going to expand it. So what this one here is saying is that I got sine of x plus cosine of x times sine of x plus cosine of x. And I am going to expand it by distributing on here and expanding it. And then it's going to be plus, and then you're doing the same thing here. So you're going to get sine of x minus cosine of x, and then sine of x minus cosine of x, and you're going to do the same thing. You're going to distribute, 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 expand, combine like terms, and see what you get on there. And then here you're going to do the exact same thing. So now I have cosecant and cotangent, which, you could sort of look at it and say, oh, well, the identities, the Pythagorean identities has cotangent and cosecant together. So maybe you'll be able to use it. Maybe not. Maybe what you want to do is change it into sine and cosine on there, and that'll work as well. Remember, we can only work on one side. So if I'm working on this side, I am going to distribute this. I'm going to have cosecant squared of x, and then minus cosecant squared of x, and then plus cosecant squared of x, and then minus 1. And if you notice, these two are exactly the same except for the plus, so they are going to cancel the middle terms on there. And so that is the difference of squares. That's why we get the difference of squares there, and that is equal to the cotangent squared of x. But I still cannot work on that. I still have to get one more step here. And if you notice that, the cosecant squared of x minus 1 is when you move these around. So I could move these around. I want the cosecant and the 1 together. So that means that I'm just going to move this over. So the cos squared is equal to the cosecant squared of theta minus 1. So this, I am going to replace it I wrote cosine, but it's cotangent. I'm going to replace it with cotangent. So this here is going to be cotangent squared of x equals to the cotangent squared of x. So you're working through this one all the way at the end. So the last step on the left-hand side has to look exactly like the right-hand side of it. And then this one here, one more, and then that'll be it. So if I look at this one here, again, tangent, cotangent, secant, and cosecant. Don't get freaked out on it. You could go back to make it as low as possible by using sine and cosine. So which side do you guys want to work on? It doesn't really matter. Again, what we would use on here is if we want to do it, let's do the tangent. So we're going to have the sine of x over the cosine of x plus the cosine of x over the sine of x. And then we're going to get a common denominator. So in order for me to get a common denominator, that means that I am going to multiply this. This is missing the sine of x. And so therefore I need to multiply this by the sine of x. And this one here is missing the cosine of x. So I'm going to multiply this by the cosine of x. So what we're going to end up getting here is sine squared of x over sine x cosine x plus cosine squared of x over sine x cosine x. And notice how they have a common denominator there. And so the common denominator, that means that I could write it as one fraction. And so we have sine squared of x plus cosine squared of x. And notice how I have a plus there. That plus is important, not a minus, because that is the Pythagorean theorem. Leg squared plus leg squared equals to hypotenuse squared. So that means that the hypotenuse is 1. So it's going to be 1 over sine of x cosine of x. And I could then break it up a little bit. And I am going to get 1 over sine of x times 1 over cosine of x. And that is going to be, these are identities that we could do another day. So that's going to be cosecant of x times secant of x. And that's what the left-hand side is going to be, cosecant of x times secant of x. And that is your proofs. So again, algebra skills, important. Make sure that you know these identities. Those are important as well. So make sure that you practice these. These at the beginning seem really tough, but you have to work them. The more you do them, the easier they become. And then you start like, oh, yeah, I could use this. I could use that. And so you'll be good at that. All right. Very good. Thank you.